Here are the instructions for Experiment 6, Projectile Launched at an Angle. Here's the equipment you'll be using. We've got a ramp, a photo gate, meter stick, ring stand, vernier caliper, CBL, graphing calculator, and instructions. We also have a steel ball. You're going to set the ramp at a rather low angle, and just like in the last experiment, you're only allowed to run the ball down the ramp as long as you catch it before it hits the ground, because the purpose is to predict where it's going to land. When you set up your photo gate, make sure that the electric eye of the photo gate is above the end of the ramp and at the very, very end of the end of the ramp, because you want that final velocity. You also want to make sure that that electric eye lines up with the widest part of the ball at the ball's diameter. This will take a little bit of adjusting. Finally, you want to make sure that the bottom of the ball to the ground is the distance that you measure. You need to measure the diameter of the ball itself using a vernier caliper. Make sure that the ball touches but is not too tight against the vernier caliper when you take your measurement. Refer to the video that you watched so that you can read the measurement that the vernier caliper gives you. Then you're going to use your photo gates. The instructions are listed, and they're to the right there. Just a couple of reminders that to arm the CBL, you have to run your hand through the gate, and the light will get brighter for a minute, but it will stay on. Then you press enter on the calculator, and then you can run the ball down the ramp. And when the ball breaks the beam the second time, the light will go off. And when you press enter, you will see the time recorded by the CBL calculator combination. When you are ready to launch your ball, when you've done your calculations, please call the teacher over. You'll take the target and you'll place it on the ground. You want to hit the 0% error line. So line that up with the range that you've figured out, and then you'll put the carbon paper face down on top of the ramp. You will need to determine the angle of elevation of the ramp, and I recommend using SOHCAHTOA to do this. In particular, you should use sine. Measure from the bottom of the end of the ramp down to the table. Measure the length of the ramp. Now you have the opposite side and the hypotenuse, and you can use sine to find the angle of elevation of the ramp. You need to think about the angle at which the ball leaves the table. Let's pick a new color, and let me sketch in the horizontal. If we use vertical angles, we can see here that the angle of the ramp is the same angle at which the ball leaves the table. And this angle is very important. We need to use it when we calculate the time it takes for the ball to hit the ground and its horizontal distance. Now, in the last lab, you may recall that in order to find time, we used delta y equals 1/2 g delta t squared. Now, in this lab, our initial velocity is not 0, so we have to take that into account. In this lab, delta y will equal the initial velocity in the y direction, which is the velocity of the ball times the sine of this angle. And think about this. The velocity of the ball is below the horizontal, which means that the vertical component, this is vi sine theta, should be a negative value. So delta y equals vi sine theta delta t plus 1/2 g delta t squared. In order to find the horizontal displacement or the range of the ball, in the last lab we used delta x equals vx delta t. And in this lab we're using the same idea, except vx is a component of the velocity of the ball as it leaves the end of the ramp. So, making the appropriate substitutions and using what we know about trigonometry, we will say that delta x will equal vi cosine theta delta t. So again, you are going to need to use those two formulas, this and this, in order to correctly determine the range of the ball.